Our solar system is a place of immense scale and breathtaking beauty. We often think it ends with Neptune, the distant blue world, the eighth and final giant planet orbiting our star, the Sun. But the story doesn't end there. Imagine journeying far beyond Neptune's orbit, into a realm of profound cold and darkness. You'd enter a vast, sprawling disk of icy debris, a cosmic donut. This is the Kuiper Belt, a frontier region, a ghostly ring of frozen worlds. Not empty, teeming with objects of many sizes. Small, icy chunks, worlds hundreds of kilometers across. Think of it as a second asteroid belt. Much larger, more mysterious. It's estimated to be 20 times as wide and perhaps 200 times as massive. The objects aren't rocky like asteroids but are made of frozen volatiles, water, methane, ammonia ice, ancient deep-frozen relics preserved in unimaginable cold. The Kuiper Belt begins just beyond Neptune at about 30 astronomical units. An astronomical unit, or AU, is the distance from the Earth to the Sun. So it starts 30 times farther from the Sun than Earth. It stretches outward to about 50 AU, creating a thick, flattened ring. Here the Sun looks like a bright star. Light and heat are drastically diminished, leaving this realm in a perpetual, frozen twilight. Every great discovery has a story, and the naming of the Kuiper Belt is no exception. While its existence was hypothesized by several astronomers over the decades, it is most famously associated with the Dutch-American astronomer Gerard Kuiper. In 1951, Kuiper theorized that a disk of material should naturally have existed beyond the giant planets as a remnant of the solar system's formation. He suggested that this region would be the source of certain types of comets, those with relatively short orbital periods. He imagined it as a nursery for these icy wanderers, a place where they reside until a gravitational nudge sends them hurtling towards the inner solar system. However, the honor of its discovery is shared. The first direct evidence didn't arrive until decades later. In 1992, astronomers David Jewett and Jane Liu, after years of painstaking searching, finally found the first Kuiper Belt object, other than Pluto. They named it 1992 QB1. This discovery opened the floodgates. Suddenly, astronomers knew exactly where and how to look, and soon hundreds and then thousands of these distant, faint objects were being identified. The region that Kuiper had imagined was proven to be real, a vast and populated frontier that had been hiding in plain sight, just beyond our technological reach. For most of the 20th century, Pluto was simply the ninth planet, a lonely outpost at the edge of the known solar system. But the discovery of the Kuiper Belt in the 1990s changed everything. We began to realize that Pluto was not alone. In fact, it was simply the first and for a long time, the only known member of this vast new class of objects. Pluto, its 5 moons' tenuous nitrogen atmosphere, was revealed to be a king among a previously unknown kingdom of icy worlds. This realization ultimately led to the reclassification of Pluto as a dwarf planet in 2006, a decision that recognized its true context as the largest and most complex member of the Kuiper Belt. Pluto is not the only dwarf planet lurking in this distant region. In 2005, a team led by astronomer Mike Brown discovered an object that appeared to be even more massive than Pluto, named Eris. This distant world has an extremely elongated and tilted orbit, taking it far above and below the main plane of the solar system. The discovery of Eris was a pivotal moment. It forced the scientific community to formally define what it means to be a planet, leading directly to Pluto's reclassification. Eris, its small moon dysnomia, proved that the outer solar system was home to a whole family of large, planet-like bodies. For centuries, the Kuiper Belt was a realm known only through the faint, reflected light captured by telescopes on Earth. Its worlds were little more than faint dots, their true nature shrouded in mystery. That all changed on July 14, 2015. On that day, NASA's New Horizons spacecraft, after a journey of nearly a decade and 3 billion miles, flew past Pluto and its system of moons. For the first time, humanity saw a Kuiper Belt object up close. The images sent back were nothing short of revolutionary. They revealed a world of stunning complexity and geological activity, a place we never could have imagined from afar. The pictures from New Horizons transformed Pluto from a fuzzy point of light into a vibrant, dynamic world. We saw vast plains of frozen nitrogen, colloquially named Sputnik planitia, that showed signs of convection, meaning the ice was slowly churning like a lava lamp. We saw towering mountains made of water ice, some as high as the Rocky Mountains on Earth, floating atop the softer nitrogen glaciers. We saw evidence of a thin nitrogen atmosphere and a hazy, layered sky. So, why does this distant frozen realm matter so much to us? The answer is that the Kuiper Belt is a scientific treasure trove. It is our most direct link to the conditions that existed when our solar system was first forming. The planets, including our own Earth, have been geologically processed and altered over billions of years. Their original material has been melted, reformed, weathered. But the small, frozen bodies of the Kuiper Belt have remained largely unchanged, preserved in the deep freeze of space. Studying their composition is like analyzing the original recipe that cooked up our entire planetary system. Furthermore, the Kuiper Belt is thought to be the primary reservoir for what are known as short-period comets. These are the famous comets like Halley's Comet that visit the inner solar system on predictable schedules of less than 200 years. Occasionally, a gravitational disturbance can knock one of these icy bodies out of its stable orbit. A close pass between two KBOs, the subtle, persistent pull of Neptune. This sends it on a long journey towards the sun. As it gets closer, the sun's heat causes its ices to vaporize, creating the beautiful tail and coma that we recognize as a comet. The study of these objects also provides crucial context for planetary science. By observing the diverse array of worlds in the Kuiper Belt, fast-spinning Haumea, complex dwarf planets like Pluto, we learn about the different evolutionary paths that planetary bodies can take. The discovery of a subsurface ocean on Pluto, for instance, which is now strongly suspected, would radically change our ideas about where liquid water, and potentially life, could exist in the universe. The Kuiper Belt is a frontier in the truest sense of the word, echoes of our creation, secrets we cannot yet even imagine. The exploration has only just begun. If you learned something new, hit like and subscribe.